In today's lecture, we're going to be talking about simple experiments. And there's a lot to be talked about when we use the word experiments. A lot of what happens in our study of human behavior are experiments, but there's also a difference between a true experiment and what's often called quasi-experiments and non-experiments. So just to kind of put it in perspective, a true experiment is what we're talking about and using the term simple experiment. In other words, it's going to have certain components, and the goal is actually to get at causation. Now, quasi-experiments are going to be any experiments that are trying to be close to a true experiment, but are missing some of those aspects we're going to discuss in this lecture. And a non-experiment is basically where we're just gathering data. There's no real experiment going on. We're just trying to know the world and people's behavior within the world better. And all of them have their places in our ability to understand. In fact, most of our major understandings of how humans behave are from a combination of true experiments, quasi-experiments, and non-experiments. In other words, what's actually happening in the real world, what's actually happening when we try to adjust a little bit of what's going on, we try to kind of one of the expressions that were used in the 1800s was to twist the tail of the tiger. In other words, it's not enough just to know what a tiger looks like. We need to know how a tiger acts. And in order to know how a tiger acts, we have to interact with it. And that's really what we're getting at with quasi and true experiments. We're not just observing the world, we're taking an active part and we're changing something in it to see what happens. In a quasi experiment, we're unable to completely eliminate any other possible explanations. The goal of a simple or true experiment is to basically get to causation, and we're going to talk about what causation means. Very few studies, by the way, that we see in mass media are true experiments. So two examples of simple or true experiments. One of them is seeing red and one of them is eating pasta, and I'm going to go over both of these briefly. But the seeing red study basically has all of the components that we're really interested in. It basically is doing the twisting of the tiger tail. And in this case, it's adjusting what participants are being exposed to. Are they being exposed to red, green, or black color in a booklet of anagrams? And once they open that anagram, do they see red, green, or dark gray print? And does that affect their success within completing those anagrams? So we have an independent variable. An independent variable is something that we're usually going to take control of. In this case, it's randomly assigning people to get one of those three packets. And we have a dependent variable, the outcome variable. How many anagrams are successfully solved? An even simpler experiment is simply eating pasta. In this case, again, we're going to use random assignment, and I'm going to talk about random assignment in more detail in this lecture. But basically, everyone that comes into the study has an equal chance of randomly being assigned to a condition. Those conditions are our independent variable. And in this case, with the eating pasta study, it is randomly determined whether someone is going to get pasta in a small bowl, or actually a medium bowl, or a larger bowl. In both cases, the bowls are very filled with pasta. The outcome, the dependent variable, is the amount of pasta eaten. So both of these are actual experiments. Now they've been simplified and they're in your textbook as well, but we're also going to be looking at the outcomes. So what we see here on the seeing red study is, again, what's being changed is three variables, whether people are seeing red, green, or black dark gray. And these are in basically the booklets that people are being handed out and being asked to complete anagrams. And the outcome is the number of anagrams that are collectively determined. And again, we can kind of see this in the top graph is actually just looking at the ink color of the actual booklet itself. So we're seeing the number of correct anagrams within this thing based on whether that color is, I'm sorry, the ink color of red, green, or black. We're also looking at the booklet color cover. And again, in this case, we're breaking up not just anagrams, but specifically vocabulary and math. And what we're finding is a consistent pattern. When people see a booklet that is colored red and is looking at red text, they do perform poorer. They do less anagrams. They do less math problems. They do less vocabulary problems. Generally speaking, they perform similarly when they're looking at green, black, or gray. Now, we do see a little bit of variance here, and we'd have to look at the statistics to find out if this was significant. But we find that when we're looking at anagrams, they actually tend to do better if it's dark black ink color versus green, and both of those better than red. When we look at the number of items correct when we're looking at vocabulary, they actually perform better in good green condition and a little worse in the dark gray condition. But again, both are better than red. And we don't really see much of a difference, though there's a slight hedge towards gray when we look at math. So when we're looking at these experiments, we want to think about some of the key components that are required for us to be doing a simple or true experiment. When we look at eating pasta, we also find that the outcome is how much actual pasta is served versus the estimate calorie count. And in both cases, people actually took less pasta when the serving size was smaller, and they consumed less calories when the serving size was smaller. So when we're talking about experiments, the main reason that researchers do experiments, generally speaking, is these first two, A and B, to have a more valid study. So remember, when we're talking about validity, we're talking about, can we trust what's happening within the study itself? And because of that, we're using these true experiments or simple experiments to make causal claims. We're basically saying that if we do find a result, there's no other possible explanation for why we found those results. Now, we may also be using true experiments, especially if there's larger sample sizes or the sample sizes are from multiple locations, to generalize. We may be using it to collect evidence in the real world. It is possible to do true or simple experiments in real world settings, though it is more difficult and often more requires more resources. And also just to be more scientific. So there may be, for example, a body of research that has been finding a trend, but no one's actually brought it into the lab yet. So we may be trying to actually firmly determine what is the cause. So for example, we might find a trend that aspirin reduces heart attacks. We might start to just see that trend, that when people have heart attacks, they're more likely not to be on aspirin, and if they recover quickly from the heart attack, they're more likely to be on aspirin. We may actually do some quasi-experimental studies where we basically start giving anyone that comes in with a heart attack in certain hospitals aspirin, and at that point we see, do they actually recover quicker or are more likely to recover? That would be a quasi-experimental. To be truly scientific, we would actually need to take people that are on the verge of a heart attack or induced a heart attack, and then either randomly give them aspirin or not. Now, most of us are aware that a small dose of aspirin is very successful at reducing the long-term negative effects of heart attacks, and actually taking a small baby aspirin if you're in the middle of a heart attack can often lead to a better result. This actually has never been scientifically, causally determined by a true experiment because there's ethical concerns. If we actually have a lot of evidence that's suggesting that this is indeed a fact, if we try to do an actual experiment, there would be some true ethical concerns about the people that were not assigned to get that aspirin. So when we're looking at experimental variables, you've already heard me say independent and dependent variables. Independent variables are going to be our causal agents. They're generally going to be what we believe is causing a difference. And they're also going to be what we often take control of. They're going to be the tail of the tiger that we're twisting. And there's going to be dependent variables, the outcome variables, what we think the independent variable is causing. In other words, how can we detect if there's a difference? In our pasta study, it was simply amount of pasta grabbed. That was a dependent variable, and amount of calories consumed. That was a dependent variable. In our red versus green versus black, dark, gray study, we were looking at anagram solved, vocabulary problem solved, and math problem solved. In other words, does color affect performance on tests? Does size of bowl affect calories consumed? Each one of those, there's an independent variable and a dependent variable, and there's an implicit causal control. Control variables are when we're asking, is there any other potential explanation? And if there is some potential explanations that we cannot control, we will at least measure those variables as control variables. So for instance, if there was no way for us to actually adjust the font that was used with the three different prints. In other words, we knew that we had a red booklet, a green booklet, and a black gray booklet. However, the red booklet had a different font than the green and black gray templates. At that point, we'd also be, is it possible that it's not color, it's font that's affecting the performance? We'd want to adjust for that. We'd want to measure that difference, and we want to find out, is that actually a cause? And that might require us to print up additional packets with different fonts in them. So why experimental experiments, true experiments, or simple experiments support causal claims? They fulfill the three rules for causation, and these three rules were first suggested by the philosopher Mills. So these are often referred to as Mills canons, C-A-N-O-N. That's not necessarily a weapon, that simply means they're kind of rules or laws. The first one is that an experiment has to establish covariance. In other words, there has to be a statistical relationship to begin with. The second one is that there has to be temporal precedence. The cause has to precede the effect. In other words, your independent variable has to happen before your dependent variable. And this is where a lot of experiments do not actually become true or simple experiments and cannot talk about causation. If we're simply measuring two variables, it's hard to make an argument that one came before the other. If we're looking, for example, for ice cream usage and amount of crime, which came first? Crime leads to ice cream or ice cream leads to crime? We don't know. We simply know there's a relationship. So there has to be, within the methodology of the experiment, an establishment of temporal precedence between your independent variables and your dependent variables. And finally, the experiment itself has to be well designed. It has to have internal validity. In other words, this is a way to say there has to be no other potential cause outside of there's an actual causal claim. And we'll talk about that in the next slide with a little more detail. So again, breaking this down into covariance, temporal precedence, and internal validity. And internal validity will often simply be referred to as there are no other possible explanations. So covariance, one, is there a difference? Independent variables answer the question compared to what? Ways to create comparison groups. So we want to think about how do we create the independent variable? How do we control it to where we know it comes first? And both of the simple experiments that we gave at the start of this lecture, I gave, were examples of taking temporal precedence. The type of color came before people's performance. We had temporal precedence. But also, if we found a difference between those three variables, green, red, gray, black, we also can talk about that there is a relationship between them and performance. So temporal precedence, usually yes, because the IV is manipulated and it comes before the DV. So that's one of the advantages of a true experiment or a simple experiment, is that we've taken control of the IV and we know it's happening before the DV. And finally, internal validity. This is probably the most important and what we're mainly going to focus on for the rest of this lecture. Are there design confounds? Are there selection effects? So there's two big questions. Methodologically, have you set up the study in such a way that nothing else could vary other than your independent variable? And are you clearly measuring a dependent variable that would be affected by those changes in the independent variable? If there's any other additional potential causes, can you identify them and can you measure them? And they would be defined as control variables or confounds. And finally, how are people being selected into your study? In other words, how are people being assigned into your independent variable? So internal validity, our potential threat one is design confounds. Another variable accidentally varies systematically with the IV. Correction can often be a control variable. So for example, again, I already mentioned this, but let's say that not only was there's a difference in font on all three. The black is Times New Roman, the green is actually in Comic Sans, and the red is in Arial. In that case, what we want to do is we'd also want to take control of the font style. And basically, we'd want 1/3 of the black ones to be in Times Roman, 1/3 of the black ones to be in Comic Sans, and 1/3 of the black ones to be in Arial, and likewise for green and likewise for red. And therefore, we can actually, one, control for that variable in our methodology, but we can also then look for differences being caused by that. So we can actually look for both of those effects then. Is it a color effect, or is it a font effect, or is it a combination? Our second potential threat to internal validity is selection effects. This means systematically different type of participants are in two groups. The general correction for this is to either do random assignment, or if random assignment is not possible for ethical reasons, potentially matched groups. So random assignment is going to work better with larger populations. So for example, if we only had 4 people in our study, 3 of them of average IQ and 1 of them an outlier with an extremely high intelligence quota, that extremely high person is going to end up in one of our groups. However, if we had 50 people randomly being assigned, the chances of only having 1 person on either end of the intelligence spectrum is fairly small. We probably have multiples, and they probably would be assigned randomly to the different groups. As I said, random assignment is our best tool for countering systematic differences between our people. And the problem for this is if we're actually doing an independent variable, let's say we did medium bowls versus large bowls, but instead of using random assignment, we just let people select. Would there be a good chance that people that eat less and therefore are actually thinner would grab the medium bowl, and people that eat more, are larger, both physically and potentially overweight, would grab the larger bowl? In that case, we have a systematic, different people are self-selecting into different parts of the study. If we're looking at a school, for instance, and we're comparing 2 classrooms, and one of those classrooms is a gifted classroom and one of those is a remedial classroom, there's already a difference between our participants. So whenever possible, we're going to use random assignment. We're going to put everyone that's going to be in our study into a pool and randomly assign them into our conditions of our independent variable. If this isn't possible, we then want to ask ourselves, what are potential confounds that could happen within these people? For example, if it is IQ, we might actually measure IQ before the test, identify people between low IQ, medium IQ, and low IQ, and then make sure that we randomly assign within each of those conditions. So we make sure that there is an equal or near equal number of people with high IQ in all 3 groups, a near number or an equal number of people with the next highest, etc. That would be matching people. So we're no longer using random assignment. We're assigning people based on anticipated control variables. So that breaks us down into 4 basic designs for experimental research. Now, there are many more designs in this, many more complex designs, but we're looking at simple, what I'm referring to as simple true experiments. So the first one is probably the most simple experiment we can have. So that is to the top left, and that is an independent groups design post-test only. We get a group of people together. Let's say we get 30 people total. We randomly assign them to 2 different conditions of our independent variable, large bowls and small bowls. And then at the end, we measure. So we measure how much pasta they actually took. That would be our measure on the dependent variable. So this is the most simple design. We could also do an independent groups design pre-test, post-test. So this is the bottom left. In this case, we again randomly assign people, but before we actually do the experiment, we do a pre-test of that experiment. So basically, before our intervention, we actually pre-test. We'd give everyone large bowls, and we'd have everyone grab pasta, and we'd measure how much pasta they grabbed. And we'd record this. The next day, we'd bring them back in, and then based on that random assignment, we would then give them either medium or large bowls, and then we'd actually give the post-test. This gives us actually more information. It basically makes the argument, were they the same beforehand? Are they different after our intervention? Because what we had hoped to find is that random assignment worked, and that our pretest shows no difference. We then do our intervention, which is our independent variable, and then our post-test, which is measuring the same variable, would show a difference. This makes an even stronger argument. And this is often the design we're going to use with smaller samples. The smaller the sample, the more we have to worry a little bit, did random assignment do its job? The larger the sample, and by large I mean 100, 150, 200, any number over there. Generally speaking, if we're looking at less than 50, we may want to think about a pre-test, post-test design. Now, the downside to the pre-test, post-test design is it takes more resources, it takes more time. We bring people in for that pre-test. In some situations, we may have to wait a day for them to come back in. Does everyone show back up? That can be problems as well. Now we're going to look at the right side, within group designs. So these are concurrent measures. They're often referred to as within groups or repeated measures design. Again, the simple one at the top right is we have a single group of people. So in this case, we have 30 people. We don't randomly assign them to different groups. We randomly assign them to what conditions they see. So they may randomly be assigned to see a female face and then do their outcome, and then they're randomly assigned to see a male face. The difference here is that everyone is exposed to all levels of our IV. Our IV in this case is female faces versus male faces. Our DV is looking preference, but everyone is exposed to both faces. And we'll talk about some of the advantages and disadvantages of this in upcoming slides. We could also do a within groups design. This is the more complex to the bottom right, and this is the fourth type of design. A within groups design where they're exposed to both IVs, it's measured, and then they're exposed to the other IV. So again, we have the same 30 people. 30 people are randomly assigned to be exposed to IV level A and IV level B, large bowl versus small bowl. We then do the measure. They then come back the next day, and the same people are flipped to where now everyone is exposed to, that was exposed to the medium bowl the first time, are exposed to the large bowl. Everyone that's exposed to the large bowl is now exposed to the medium bowl. And again, we measure the DV. And all of these have advantages and disadvantages that we're going to go over, but these are the four basic designs of simple experiments or true experiments. Independent group post-test only, independent group pre-test post-test, within group concurrent measures, within group repeated measures. So the advantages of a within groups design, this is the same people, this is a repeated measure, is we truly have a matched design, and we need fewer participants. So statistically speaking, if we're randomly assigning people into separate groups, in other words, it's different people in group A and B, we're going to probably need more participants. Let's say our minimum per condition is 15. We'll need 30 to give them to condition A and condition B. If it's 15 and we have 3 conditions, we're going to need 45 people. However, in this type of design, all we need is the number of people for whatever condition we're looking at. So let's say we have a condition where it's three different conditions, but everyone's going to be exposed to all 3 conditions. We need 15 people. We need 15 people. 15 people are exposed to condition A, B, and C because they're all being exposed to all conditions. And that's why it's fewer participants. We also don't really need to hope that random assignment is working. So there's less need for a pretest in this condition because it is the exact same people that are being exposed to all levels of our independent variable, our tweak of that tiger's tail. The disadvantages of this repeated measures. There are order effects. Participants' later responses are systematically affected by earlier ones. In other words, it may be fatigue, it can be practice, it can be carryover. So think about this, for example, if we're actually doing the outcome that we started with, that's the actual packets. You're doing anagrams, math, and vocabulary. So you get the red book. You do all 3 activities. Then you get the blue book or the green book and you do all 3 activities. And then you get the red book and you get 3 activities. Are you going to potentially figure out your mistakes or just get worse? So practice effects is you get better over time, not because of the color conditions, but just because you've been exposed now to these problems 3 times. Fatigue effects means you get worse over time because you just get tired of taking the same test. Could also be carryover effects. You're now learning the procedures. So the first time you did the anagram, you may have come up with one answer. The second time, you're like, I've been exposed to this before. This isn't necessarily practice effects. This means I've had experience with this, and I've been thinking about it, and I now have a better answer. So the correction to this can be counterbalancing. In other words, we randomly assign people the order they're being exposed with. So for example, if I was looking at the experiment that's listed here below the slide where you interact with your own toddler or you interact with a new toddler, I could randomly assign people to which version they're being given. So these aren't conditions. The conditions are still interact with your own toddler or interact with a new toddler. But everyone's going to be interacting with both of these. But half of my participants randomly are going to first interact with their own and then second interact with a new toddler. The other half are going to interact with the new toddler first and then interact with their own. So that's counterbalancing. If we were doing a more complex design like the red, green, black study, a third of people would get red first, a third would get black first, a third would get gray or green first. So again, the practicality here is it is getting more complex. And also there is still going to be demand characteristics. The demand characteristics are that in a true experiment that is used random assignment, no one actually is getting exposed to the entire experiment. In other words, you have one condition. I completed a packet with the red cover and red ink. I don't know what the other conditions are, which means that there's no demand upon me to maybe figure out what's going on. In this case, as we're being exposed to additional conditions, I'm going to be exposed to the red edition. I'm going to be exposed to the green edition. I'm going to be exposed by the black edition. By the time I hit the black, I've probably figured out, oh, they're looking at the effects of color. So it is more likely that our participants will start to understand what we're actually researching because they're being exposed to all levels of the independent variable. So there are pros and cons to both. The independent group design does require more people, but there's no contamination across those independent variable levels. In other words, people don't know what you're actually studying. They're less likely to guess it. The advantages of within group designs requires fewer people. The individuals serve as their own control, so we're not having to rely on random assignment. And there's the downside of potential order effects and chance for experimental demands. And experimental demand simply means people figuring out what you're studying. And if people can figure out what you're studying, then we start to worry about, are they trying to actually prove your theory or are they trying to disprove your theory? So for example, you might have a participant that figures, oh, you're interested in color, and they get the red one at the end. Oh, I've actually read a study that said that you perform worse in red. Well, I don't agree with that, so I'm going to try harder now. That's demand characteristics. People have figured out what, and now they're making demands on the study themselves. So integrating causal claims with the four validities. We're talking mainly about construct validity and internal validity and statistical validity in these cases. And that's the main thing that true experiments or simple experiments really address. So construct validity still is very valid. How well are the variables measured and manipulated? I'm going to skip 2 and go down to 3. Statistical validity. How well does the data support your causal conclusion? Do you actually find a reliable covariation between your variables, your independent variable and your dependent variable? And internal validity. Are there any alternate explanations for the outcome? And this is the most important validity for true or simple experiments. Now, once you actually have those 3, then the argument becomes, do you have external validity? To whom and to what can those causal claims be generalized? And this is generally one of the more weak parts of a true experiment. Because true experiments are completely controlled, often the rooms are controlled, the temperature is controlled, all other variables are held stable. That also means that there's a lot of artificialness built into the experiments. Now, this can be addressed in certain ways. I actually used to work as a graduate student decades ago in a pot lab, so marijuana. We actually studied the effects of marijuana on people. So people would come in, and this was a state where, and especially a time, where marijuana was illegal, but they knew they were in an experimental condition. There's no question they were coming to a psychology department to come into a room to take part in a study where they either got a placebo or they got actual marijuana. By the way, if you've ever wondered, medical grade marijuana that is actually authorized for the use in psychological studies is not very good. This is given to me by everyone that was in our study. However, where they actually were brought in, they were brought into a research lab in a psychology department. However, we had changed that space to look like, for lack of a better term, a pot den. There was a lot of bean bags, there was Jimi Hendrix posters on the wall, there was lava lamps, there was weird mood lighting, there was a stereo system. All of it was to make it feel more natural. Also, when they were done with the experiment, they had to stay there. Often we had videos and movies for them to watch. If, for example, generally speaking, I'm more familiar with alcohol, but for every ounce of alcohol you consume, it takes about an hour for you to fully recover from the effects. So if you have 3 ounces of alcohol, the average person is going to take 3 hours to fully recover. There was a similar chart for marijuana usage, so we had to return people to the same condition, not inebriated, before we left, so they often were basically required after the experiment to hang out and watch movies. So finally, I just want to briefly touch on the assignment for Chapter 10. For these, you're going to basically review studies. For each study, I want you to tell me, is it a between or within groups, and which of those 4 designs were used? So again, think about what we've talked about in this lecture, and definitely use the slide for help. What internal validity problems could you think about? So think about internal validity. Is there issues with how the actual study was done, how the variables were manipulated, or how the variables were measured, and what were those variables? What was the independent variable and what was the dependent variable? So that's the task that you have ahead of you on assignment 10.